Okay, so now in this video, we're going to discuss word problems at a grade 10 level. All of these words that you see here, I've already introduced in the grade 9 playlist. So if you go to the grade 9 playlist, you'll see under the word problems, the introduction video, watch that video, and then refer back to this video and watch all of the problems that we will solve. Right, so there's just, it's just basically a repetition, and I delve in deep explaining each of these words and what they mean and what operations we perform when we see these words. So let's move on to the first problem. Sarah wants to invite 50 friends to a party. If the cost to invite 50 people is 2,500, so 50 people is equal to 2,500 rand, right? How much will it cost to invite 25 friends? Assume the cost to invite each friend is the same, right? So what we can do is, see what we have here, right? We have the 2,500 rand for 50 people. So if I can find the cost to invite one person and then multiply it by 25, I'll be able to find the cost to invite 25 friends. So this is what we'll do. We'll say, okay, 2,500 divided by 50 people will give you 50 rand per person. Now, if you watch my units of measurements video, you will know exactly why units of measurements are so important. Because you have rand, you have people in the bottom. So when you divide it, it'll be 50 rand per person. And obviously, it's a single unit now. You're finding for a unit. For a single unit, what does it cost? So from many people, what does it cost to invite one person? Understood? That's what we talked about in the unit of measurement video under grade 9. Then if you take this 50 rand per person, it's 50 rand over one person. Watch this how the units of measurement works out. And then you multiply it by 25 people. Right, this and this will cancel, so therefore you are left with 50 times 25, which is 1,250. That's the answer, right? Or alternatively, if you watch my ratio and proportion video, you'll see I structured it out like this, where we spoke about equivalent ratios. See, 2,500 over 50 people should be the same as X rand over 25 people. It's the same thing. They have to exist. Basically the ratios are equivalent. So therefore, if I have to solve for x is equal to 2,500 divided by 50 multiplied by 25, and we should get the same answer, 1,250. Exact same thing, right? So that's how you would solve a problem of this nature. Okay, let's look at this problem. You intend on tiling your lounge. However, you need to find the area of the floor in order to purchase the correct quantity of tiles. Consider the diagram below. So you can see you have an oblique shape here. We don't know what the shape is. But as I've said in the introduction, in the grade 9 introduction video, I said that when you solve word problems, you're going to start off with what you know and then move to what you don't know. Right? So we start off from the known. So we go from the known to the unknown. That's exactly what we're doing. So what shapes do we know the areas of? We know the areas of rectangles, squares, and triangles. So what we'll do, we'll break this complex shape up into squares and rectangles, find the area of each part, and then we can add all of the areas up, right? And it should give you the same answer. So let's look at shape A. If you look at shape A is 20 units by 20 units. So therefore the area is equal to S squared, side squared. So it'll be 20 multiplied by 20, which will give us 400 units squared. Then we look at shape B. Shape B is what? A rectangle. The area is equal to a half base times height. Therefore, we have half. The base is 20. The height is 20 as well. So you should get 200 units squared. Then if you look at shape C, we have a square as well. Right, so area is equal to side squared, which is equal to 20 squared, which is equal to 400 units squared. So therefore, if we add all of these values up, 400, 200, and 400, we should get 800, 1000 units squared. So that's the area of the room that we intend on tiling. Alright, and then you can see exactly as I've stated here, we would first need to break this irregular shape into smaller triangles and rectangles because we know how to find the areas of these shapes. Finally, add the area of each piece to get the total area of the room and round up if necessary. This is a very important idea because when I talked about my rounding up and estimation video at the beginning of the grade 10 course, I said that when you look at problems practically from a real sense, you always want to round up, right? And especially with building material, you rather have more than less because you have to account for offcuts and so on, right? So that's the more practical answer that you should give. So if we had decimals here, you'll always want to round up. Right? So ensuring that you have the unit squared is very important, especially when you're dealing with area and perimeter. When you have perimeter, you'll obviously just say units. If you have area, you have to say units squared. And obviously, if you have volume, then you'll say units cubed. So if they do not explicitly state a unit of measurement like meters, centimeters, or kilometers, you have to use the word units, right? Think about word problems practically. All right, let's look at the next word problem.